Welcome to FYI, the For-Your Innovation podcast. This show offers an intellectual discussion on technologically enabled disruption, because investing in innovation starts with understanding it. To learn more, visit arc-invest.com.
ARC Invest is a registered investment advisor focused on investing in disruptive innovation. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. It does not constitute, either explicitly or implicitly, any provision of services or products by ARC. All statements made regarding companies or securities are strictly beliefs and points of view held by ARC or podcast guests and are not endorsements or recommendations by ARC to buy, sell, or hold any security. Clients of ARC Investment Management may maintain positions in the securities discussed in this podcast.
All right, today I'm joined by Manu Sharma, the founder and CEO of Labelbox. So welcome to the podcast. To kick it off, would you start by just telling us what Labelbox does and the origin story behind why you started the company?
Absolutely. Well, thank you for having me, first of all. So Labelbox builds software products to develop and improve mission-critical AI systems across wide-ranging industries, from agriculture to robotics to healthcare and insurance and defense. And the origin of Labelbox really came from our own experiences of building production AI systems. So before Labelbox, I was at a company called Planet Labs, and it's been an exciting company that came out with a new approach for satellite imaging. They were the pioneers of making small satellites work in low Earth orbit. They had, I think, hundreds of satellites in orbit when I was working at that company. And we could scan the entire Earth every single day. Just imagine if you have Google Maps and albeit a low resolution, that it just refreshes every day, what kind of insights you would be able to gather. So we could track deforestation in any country at any given day. We could understand objects such as cars in parking lots, in parking lots of like Walmart, and essentially provide index of that to companies that would care about that, such as hedge funds, and sometimes use cases for national security, understanding what's happening in certain regions and so forth. Now, a lot of these insights that we were building were actually driven by AI. Imagine if you have so much images just come to your desk every day, it is almost impossible for an analyst or a human to extract insights and make it useful. And so the obvious answer for us was to build computer vision systems at scale that would power these applications. And this was, I believe, around 2017, 2018, when computer vision was really taking off. It was first time we were seeing AI applications powering real solutions in industries. And for the first time, we could see these systems exceed human capabilities in a narrow domain. And it was no longer a elusive idea that, that only a handful of companies gets to build AI systems. It was becoming more of a industrial version or industrial tools. Like you could follow a recipe as long as you have the data, and as long as you build the right tools and workflows, anybody could develop AI systems. And that was certainly the case for us. So we actually built a ton of tools to label data the way we wanted it, and then manage all of the data processes, and then tie it really closely with model development processes. And, we realized at the time that this is going to really change the world over time, because in essence, we saw a paradigm shift from how applications were starting to be built. From writing logic, generally most of the world around us is built with software. And software is essentially understanding business problems and decomposing it into logic. And that is how software is built. But with AI, certainly the paradigm is all about data. It is taking human intelligence and encoding it into data through human-computer interfaces, and the computer system is learning from it, and at some point becomes so much smarter than a human being can be. And that was all around us at that time, and we thought we could really build a great product here, because when we were building our solutions ourselves, the backdrop was there were a lot of services. There were a lot of labeling services, companies that would come to these AI shops or, the biggest FANG companies. They would say, give us your data. We'll label it for you with our crowd or with our large team of people in some facilities around the, in Asia and Pacific regions, and send the labels back to you. And it was enticing, but it was never a solution, a complete solution for companies like us. We really had to invest into a tool chain, a platform ourselves where no matter what the problem is in terms of applications, we could load up the data, create an ontology, and configure it in a labeling configuration that was needed for that job. So as an example, if you're trying to build an AI to detect certain signatures of illegal activities in countries, we really needed that domain expertise who for decades have been looking at those images and can exactly pinpoint what those actions look like. But in the case of detecting cars, anybody can look at an image and say that's a car. And so we just wanted to outsource that to the service companies. But in an organization where there are so many AI applications happening, we can't just switch back and forth through different products and services every time. And so we had to really build a platform ourselves, a product suite to orchestrate all of those activities together. And in a sense, Labelbox became that once we came out of that experience and built it.
And so what is the world like for a Planet Labs of the world today? What does their world look like before Labelbox versus after Labelbox?
Absolutely. So within enterprise, our customers at Labelbox who choose to use Labelbox are largely some of the largest organizations around the world. And these enterprises are going through rapid transformation where their AI projects are exponentially increasing, actually. And within an enterprise, let's just take an example of insurance company. You've got insurance claim adjustment for home, and maybe then that's there for vehicle. And any of these tasks require images or documents or text. And AI systems are actually unique for every data modality. And then there may be just document processing projects or a new application with mobile experiences. And so these enterprises are looking at all of these activities and investing in AI. And before Labelbox, every single team will be building their own bespoke solution for their data engine, data labeling infrastructure, whether they're going to build it themselves, whether they're going to outsource it as a service. Nearly every of those enterprises have numerous labeling service vendors or business process outsourcing vendors, because business process outsourcing is a huge industry. It's like $260 billion market cap overall. And generally these enterprises outsource a lot of work. And so these companies are becoming digital. And so they outsource them in a form of labeling services. So before Labelbox, there's just a lot of fragmentation of service providers, tools, open source systems, and not a organized workflow to rapidly iterate with AI systems. I know you guys have covered a lot of Tesla. And one of the remarkable things Tesla has been able to do is build a data engine where it's a closed loop system where the AI team is rapidly able to source all of the data, prioritize where they should be focusing on their efforts for labeling. They get it labeled. And by the way, they use a lot of automation techniques to quickly label that data and then train their models, test and evaluate those models, and then ship them back to the cars. And it's rinse and repeat. In fact, I wouldn't be surprised that they are doing this on a weekly basis or like really quickly. And nearly every enterprise wants to get to that state, to build this data engine for their applications and iterate as fast as possible. With Labelbox, they're able to do that. They're able to rapidly take their data, get it labeled however they want, whether it's internal teams of domain experts, or if they want to use labeling service vendors, they can orchestrate that on the software platform itself. And we are used by a number of some of the biggest business process outsourcing companies who use our software to to perform data labeling operations and render their services to our customers, AI customers in enterprise. Then we have a product called Catalog, which organizes all of their data, unstructured data, that is images, video, text, PDF documents, metadata, basically all of the information that is exploitable to build AI system in a single place. And we make it very searchable, visualizable, and teams can analyze and curate that data and essentially select the things that they really want to improve model performance. And then we have a third product called Model, which really is one of the very exciting things that we are doing, where we are enabling AI teams to, in the UI itself, prepare the data for model training and orchestrate these model training jobs wherever they are in Google cloud provider, like cloud providers, GCP, Amazon, Azure, or on-prem services, and then take the inferences back and do test and evaluation of these models. Just like anything that we build in software, it needs to be tested and evaluated. Our model product is all about that, because these AI systems are very different than software in a sense that the test and evaluation requires data. It requires understanding how the models are making decisions superimposed on the ground truth it was used to train in the first place, and then doing comparative or differential diagnosis. So all in all, post Labelbox, AI teams in enterprises see rapid acceleration of their roadmap, anywhere from 6 months to 18 months. They see cost reduction of labeling services, human labeling services, by up to 80%. And the reason they're able to do so is because they are using our software platform to automate all of the tedious tasks and use AI systems to pre-label the data, which I'm sure you have learned a lot about with Tesla, and only send the residual tasks that cannot be automated to the humans. And that is given through to all of the vendors who use our software to render the services to our customers.
So said simply, you're basically taking what Tesla's built with their data engine and providing that capability to any company.
That's right.
And maybe just to take a step back and talk about, how AI actually works. Can you explain why labels are important?
Absolutely. So just like we learn about the world, we associate semantic meaning to patterns that we see. AI systems are actually no different. They require information in a format that tells the models what a pattern of information really is. And so, a blob of pixels that looks like car, a model needs to really understand how to associate those pixels to a word called car. And car in this case is a label. And this is how most of the neural networks work, where there needs to be the raw data fed to the system, as well as a semantic information, like what those things mean, into the system, so that they can be useful in the real world. That is the biggest paradigm shift we are seeing with neural networks. We have had neural networks for many decades. In fact, when I was in college with Brian at Embry-Riddle, we were using neural networks that were 3 layers and 9 nodes in MATLAB and Simulink, and we were just amazed by what it could do at that time. And here we are hundreds of billions of parameters in just 10 years. And but the fundamental idea has not changed. It is, again, learning on the data and the labels fed into those neural networks.
Do you think with the rise of unsupervised learning, do you think in the future labeling will be more important or less important than it is today?
I think generally speaking, the amount of labeling the labels required is going to continue to drop. And we are already seeing that with the customers today. Generally speaking, and some of the reason for that is these pre-trained large models already have so much common understanding of the world that they only need to be fine-tuned. And to fine-tune, you essentially need to feed highly selective, high-quality information to the neural network so it can learn from that pattern and achieve superhuman accuracy. And so that is the new paradigm. Nearly every single customer I know is using a pre-trained network and essentially doing fine tuning. And so I think we will generally see less and less labels for most practical real world narrow applications. At the same time, I actually, we are seeing that the way of labels are changing too. So some of the most advanced AI teams, the labeling for them looks like in normal work that a human may be doing on a computer. As an example, writing a software logic, like writing a function. So given a problem, like write me a function that adds these 5 numbers and then do XYZ additive mathematical steps in Go. And so the human labeler would actually be writing the logic. And that is what AI systems are learning from now, which is super exciting, because these compute systems, as they get better and better, they're going to be able to abstract and generalize knowledge from kind of this natural interactions that humans have. And that is just the power of compute clearly there, and algorithms.
Yeah, completely agree. Going back to pre-trained models for a second, do you think pre-trained models, these very large models like GPT-3, do you think they'll be commoditized as, costs decline around compute? Or do you think that, companies that have proprietary data assets and pre-trained models with, some blend of proprietary data assets and public data assets will have differentiated models that are hard to replicate?
Yeah, absolutely. So the way I think about it, and this idea really came from my co-founder, Brian, and I think it's really, really right, which is there are 3 layers of the kind of things AI can do: commodity data, commodity models. So these things are, let's say, OCR or document processing. You take a photo of an invoice and it needs to be transcribed. And, I'm sure you have used a number of applications like that. And that is commodity data because it exists everywhere. And the algorithms for digitizing, identifying letters is it's available everywhere. It's a open source. There's tons of open source pre-trained models that just do that. And so this is obviously commodity, because anybody with the intent and computational resources can have access to this data and also build these models. Then there is the second layer, which is commodity data and proprietary algorithms. And this may be arguably like self-driving cars. Like you could have a bunch of sensors and can collect basically the driving on the road. Anybody can be on the road. There is no barrier to entry to collect that data. And however, the algorithms, the systems, the AI systems are highly proprietary. And so this is sort of like a second order application. And I would say not easily not a commodity, because again, it requires just so much of data in so many diverse environments. And by the way, you need to have this data engine that only a handful of companies can do it. The top of the pyramid is proprietary data and proprietary or commodity models, which is only specific companies in the world can have access to a kind of data that only their applications generate. And these companies can build AI systems on that data and basically leapfrog. What's an example of that? Healthcare companies or insurance companies. Insurance companies have so much information about our vehicles or our home, our personal information about our health and so forth. And this is not easily accessible to anyone. And so building AI systems on them is incredibly lucrative. Same thing in agriculture. So some of these companies, for example, tractor companies, there is only a handful of tractor companies that matter. John Deere is one of them, and others. And they collect so much data on the field with their sensors, and they can build AI systems. Only they can exploit that to build AI systems and provide cutting edge new solutions to the farmers and growers in the country. That it's really hard for a new entrant to do that.
into the companies, maybe the legacy companies, right? They're not John Deere and others. Historically, they haven't been technology companies per se, right? They're not software engineering companies like Google. How do they actually take advantage of that data? Do you see companies and traditional industries hiring their own AI researchers and building their own models? Or do you see them partnering with other companies to do that?
I think AI is within reach of everyone today. And nothing makes me more proud at Labelbox than seeing some of these, iconic American brands, like John Deere, and Procter and Gamble and so forth, to be building cutting edge AI systems that in many cases exceeds a lot of things that you will see in Silicon Valley. And so I'll give you an example. It's a public information. You can learn about John Deere has this new technology called See and Spray. So you can buy today tractors in Iowa that will very soon have, or may already be the case today, that they have a add-on which basically have GPUs, cameras, and spray guns to identify weeds and spray the herbicides to them. Now, before a technology like this, a farmer would have to spray herbicides basically everywhere on the farm. And with this technology, the cameras basically have a zoom lens and it figures out where that undesired plant is and will spray just the right amount to kill that weed. And it saves the growers as much as up to 90% of herbicide application. And by the way, in very large farm, thousands of acres of farm, the cost of herbicide can far exceed the cost of tractor. So these companies might as well actually provide software subscription and give hardware for free. Think about that. That is a disruption that is powered by purely AI capabilities, and that we are seeing that. You can actually go read up online about these technologies and these tractors in the field. And we power a lot of companies and technologies like that. And yes, it requires AI skills and talent. However, it is not it is not limited to a handful of companies anymore. It is out there. Everyone generally is embracing AI, and AI is going through this industrialization. Like there are industries forming, there are tools, products, services being formed that is supporting all of these enterprises to build AI applications at scale.
Yeah, it seems like this trend of hardware is becoming just a platform through which you sell software, right? This is sort of a similar possibility with Tesla, right? If full self-driving and autonomy takes over, the hardware is much less valuable than the software stack sitting on top of it. That's a fascinating thing to see across different industries. And as you see, companies adopting and embracing AI, where are they struggling? What's the hardest problem that they're trying to solve? Is it, hiring the right people? Is it labeling their data? Is it, getting access to the right computing capabilities? Where are they struggling?
I think it's a combination of problems. I think there certainly is within enterprises at large, there certainly is a challenge of reskilling or skills. There is talent shortage for data science, AI skills. Although it is changing very fast, it is not at the rate that these enterprises would want to have and maintain their roadmaps. And so the challenge is, how do they then take their current employees and reskill them to learn and build AI systems? And so that's a problem. And secondly, enterprises or teams, generally speaking, are having a harder time building this data engine, the end-to-end solution that takes the data from applications, converts them into labeled information, train models, improve these model performance to at or above a certain threshold so they can actually get these AI applications out into the field that generates ROI for businesses. And building this data engine can be challenging for most companies, especially in large organizations where there's so much complexity, so many different teams, different sensitivities to data, and so forth. And that is the problem that we are so excited to be solving.
That makes a lot of sense. And if we could maybe just take a step back and think about, like, the next 5 to 10 years for AI, we've seen this incredible rate of advancement in the last 5 years, where if you look at the capabilities of generative models around image generation 3 or 4 years ago, they were nothing compared to DALL-E 2 today. We think that the cost to train models will continue to decline at about 60% per year, which dollar for dollar results in a 2.5x increase every year in capability for the same dollar of input in terms of compute. Do you think this rate of advancement will continue for the next 10 years? Or do you think we're going to sort of asymptote and we'll start to see performance increases decay a little bit?
I'm currently in a camp that AI is now a software problem. And yes, that the hardware, the compute systems do need to be better, efficient in power too, not just in computational, but the just amount of energy required to do computation. I think we do need to get to closer to human brain over time. Our brains are incredibly efficient per watt for computation. However, I do think that the core problem of AI is now software related. It's figuring out how these algorithms work, and maybe it's a systems designs problem, etc. And because it's software, I think the rate of innovation is going to be really, really fast. And, it's very hard to predict if it will ever asymptote or not. But I think generally speaking, all technologies kind of go through this S curve. And so we are, I would say, at the very beginnings of that S curve, and in a kind of really rapid Cambrian explosion of new AI techniques, new applications, and maybe it will have asymptote, maybe it will break through to AGI systems. I don't know, but I think it's certainly very exciting times for AI.
Yeah, I would agree. If you're thinking about this from a national security lens rather than a commercial lens, it seems like AI is one of the most important initiatives countries could be working on from a national security standpoint. This is sort of the next generation atomic bomb in a way. Do you think that the U.S. in particular recognizes the importance of AI from a national security standpoint? Or do you think we're still in sort of the early educational phase of getting politicians and military leaders to really wrap their heads around the importance of AI?
I believe that the topmost officials in our military have a very good understanding and awareness of the importance of AI. In fact, that it is one of the first things that they are thinking about in terms of building development of new capabilities. And it's not just AI, but data, information, making decisions with information, and getting ready for the warfare that happens basically in digital form. And that is totally real. That is everyone's aware of that. And I think that the U.S. government, generally speaking, is a very large institution. I mean, they might be one of the biggest employer in the country. And so it's just a very complex organization where the ability to procure new technologies is slow. And if they do procure technology, the adoption and getting it to real applications can be even slower than that. And priorities change and so forth. So I think there is just a lot of friction, I would say, in this organization to rapidly adopt. And I actually have no doubt that we will overcome that overall, because I have yet to see any problem that America has not been able to overcome since the beginning. I'm myself an immigrant. I was born in a small town in India, and I only dreamed of coming to America. I had only seen it in like Discovery channels and so forth. And, within the last 12-ish years, not only I've come here, gotten my education, but I'm building Labelbox. It's, and the amount of success that I've had in this country far exceeds the tens of generations of my family that has been existing in India, right? So this amount of these kind of experiences, I believe, is the beauty of America, and it attracts the people with new ideas, and there's a freedom to act on things, and so that's the conversation that we are having with a lot of folks in the defense and national security, and I think we're on the right path.
Very well said. And just to close out, maybe we can move to Labelbox as an organization. How long has Labelbox been a company, and how big are you guys today in terms of number of employees?
Labelbox was started in March 2018. So that was the day, that was a month that we actually became a company and started working on it full time. And today, Labelbox is approaching about 200 people, primarily in North America and Europe.
And what have you learned over the 4 years in scaling the company up quickly? What do you wish you knew as a founder starting day one in 2018?
I think it's all about people, and finding people that are consistent with the values of the company and the ethos of the product is so far valuable than anything else. Like it's like collecting gems and marbles that you would always want to keep it to yourself. And finding these people are incredibly hard. And when you find them, you've got to do everything you can to allow them to do their best work and to build great products.
And there's a debate going on right now within the tech community over in-person versus distributed workforces. Where do you sit in that debate?
I think we are learning. I think I'm personally learning and understanding the nuances of both worlds, real in-office and remote. So Labelbox embraced remote culture, and we are fully distributed today because we had to in all this last 2 years. But there is something really special about being in person and getting to know people and getting to have these free-form conversations that feel sometimes a bit more limited or restricted over Zoom. And, I wonder that all the amazing things in the world that we experience today were basically built with in-person companies. And so I think the world has changed for sure. There will be companies that people will go to because of the in-person culture, and that is what they want to experience. And there will be companies and people who would want to go to the remote world. And so I think there are benefits for both. We are trying to understand what is the right balance and how do we architect ourselves and endure ourselves for a long term. And I think it's going to be some combination of both, not the one.
Have you found anything that works really well in terms of a remote culture, but continuing to maintain those social bonds, whether it's offsites or happy hours through Zoom? If you're advising a founder who is just building a team in a remote fashion, what would you tell them to do?
I would highly recommend to instill a writing culture or a culture of being extra communicative. Because you kind of have in a remote world, it's a limited information, it's a limited bandwidth compared to when you're in person, and so everyone has to be aware that they need to emit more information back and forth and just share more information to communicate ideas. And just be very specific about that. I think for us, we get really excited about offsite. So almost every couple of months, our teams gets to decide a city, and they go fly there and work together for a couple of days or a week. And I think it's very energizing for everyone. They build the bonds, and then they go back to their homes and then look forward to the next one in a few months. And that's been working really well for us.
That's great. Well, thank you so much for joining us today. If people want to follow you or the Labelbox journey, where can they find you?
Follow me on Twitter. I'm not really an active Twitter person, but you can certainly follow me there or follow labelbox.com.
Awesome. Well, thank you.
Thank you so much, Will.
ARC believes that the information presented is accurate and was obtained from sources that ARC believes to be reliable. However, ARC does not guarantee the accuracy or completeness of any information, and such information may be subject to change without notice from ARC. Historical results are not indications of future results. Certain of the statements contained in this podcast may be statements of future expectations and other forward-looking statements that are based on ARC's current views and assumptions and involve known and unknown risks and uncertainties that could cause actual results, performance, or events to differ materially from those expressed or implied in such statements.